Okay, welcome to Chapter 2. In this chapter, we are going to be exploring parallel lines, triangles, angles, those sorts of things. In this particular lesson, we're going to be exploring lots of definitions, so you might want to pause this video regularly throughout if you're taking notes along with me. And yeah, the lesson after that is going to get more practical. So this lesson is about definitions, and the next one more practical. So here are two definitions to start on. First of all, parallel lines. Parallel lines are lines that if you extend them forever, so two lines that if you extend them forever, that they never, ever, ever touch. And in this particular chapter and in mathematics, in order to identify parallel lines, what we do is on those lines, we place arrows somewhere inside those lines. So these two lines here, which I have highlighted in blue at the moment, those are parallel lines as indicated by these arrows here. Okay? Second definition is a transversal. A transversal is a line that intersects two or more other lines. So this line here, which I'm currently highlighting in pink, that's a transversal line because it's intersecting the two parallel lines. And what we're going to investigate in this lesson is different definitions having to do with parallel lines and transversals for the most part. All right, part A, properties of angles. And lots of different definitions and just some theory based on it. First of all, supplementary angles are angles on a line that add to 180 degrees. So on this particular line over here to the right, angle A plus angle B, because they're on a line, add up to 180 degrees. Okay, and the abbreviation throughout this chapter, we're going to be determining what particular angles are and stating why they are that particular measurement. So the abbreviation that we use for this particular definition is that angles on a line equal 180 degrees. So you will be helped by knowing these abbreviations because they shorten a lot of your work. Okay, definition number 2 is angles at a point. And what we know is that angles around a particular point add to 360 degrees. So if you look at this diagram over to the right, all of these angles meet at that green point, and angles A plus B plus C plus D plus E all add up to 360 degrees. And the abbreviation, as we get into more practical examples, to describe that would be this. Angles, we just use the angle sign for that. Angles at a point equal 360 degrees. Okay. The next definition, vertically opposite angles. Vertically opposite angles are angles that are opposite of each other on intersecting lines. So if you look at this, again, diagram to the right, and you see these two intersecting lines, there are two pairs of vertically opposite angles. So for example, these two, angle B and D, are vertically opposite, and they're equal to each other. Okay, so angle B is equal to angle D. Or if you look at these two highlighted blue angles, angle A and angle C, they are equal to each other because they are vertically opposite. So the abbreviation related to vertically opposite angles that we will get into in the next lesson is that vertically opposite angles are equal to each other. And these are things that will come up regularly as we practice, and you will get more used to with the abbreviations. All right, definition number 4 is corresponding angles. In the next 4 definitions, what we're going to look at is angles that are specifically related to two parallel lines and a transversal. So again, as we saw at the beginning of this lesson, we have two parallel lines, in this case these two blue ones, and a transversal, this pink one here. Okay, so parallel lines and a transversal. All right, the first definition is corresponding angles, and corresponding angles are angles that are on corresponding sides of the parallel lines and also on corresponding sides of the transversal. So let me show you what that looks like. If I look at the diagram here, angles D and H are corresponding, and the reason for that is that they're on the same side of their respective parallel lines. They're both below their blue parallel lines, and they're both on the same side of this transversal. They're both to the right of the transversal. If you look at them, they look like they are the same, and in fact they are. So corresponding angles are always equal to each other. So for example, angle D is equal to angle H, but there are other corresponding angles. Another pair of corresponding angles would be C and G. They are also both below their respective parallel lines and both to the left of the transversal. So angle C is also equal to angle G. Those are corresponding angles. Or if I look at the next example, angle E would be corresponding to angle A because they are both above the parallel lines and to the left of the transversal. This will become more familiar as we go on in this chapter. And the last pair of corresponding angles here would be angle B and angle F. So those are all corresponding angles. So the abbreviation that we are going to use is that corresponding, just CORR, corresponding angles are equal. And something that helps a number of students remember or recall, I'm just going to erase the blue and pink highlights here. Students are used to recall the corresponding angles rule is generally it can be indicated by the letter F. Okay, so if you see this here in green, this is the letter F, and the corresponding angles always fall kind of within the armpits of the F, so D and H, for example. Although the F can be rotated around or upside down and all sorts of things. So if you look here, this is still the letter F highlighted in green here. It's just upside down and backwards. But if you look at the armpits, A and E are still corresponding. So you can see that here. So what I'm going to do is put a big fat letter F here to remind you of the corresponding angle rule. So it falls within the letter F. All right, the next definition is alternate interior angles. Alternate interior angles are angles that are inside the parallel lines, but opposite sides of the, and I should put this in here, opposite sides of the transversal. So if you look at here, again, here are the parallel lines, and here's the transversal. So inside the parallel lines and opposite of the transversal. C and F are inside the parallel lines, so one is below and one is above, and they're on opposite sides of this transversal. And if you look at them carefully, you'll see that they kind of look like they are the same measurement, and they are. So C is equal to F, and another pair of alternate interior angles are angle D and angle E. They are inside the parallel lines and on opposite sides of the pink transversal line. So angle D is equal to angle E. And there is also a letter that can help you remember what alternate interior angles can come from. Alternate interior angles, if you look at this letter here that I'm going to draw in green, it's also called the Z or the Z rule. So if I draw a Z and I look in the armpits, angle C and F are alternate interior. So, and this is a lot to take in. Alternate interior angles are equal to each other, and I'll put a big Z here. Okay. All right, next. Alternate exterior angles. They are angles that are outside the parallel lines and on opposite sides of the same transversal. So outside the parallel lines, so here's the parallel lines, and opposite sides of the transversal. So for example, angle A and angle H are outside the parallel lines and on opposite sides of this transversal. And again, if you investigate, you'll find they're equal to each other. So A is equal to H, and another pair of alternate exterior angles, there's only one more, is that B is equivalent to angle G. Those are alternate exterior angles. In this case, however, there is no letter that can remind us of how to memorize alternate exterior angles. And here's the last one having to do with parallel lines and a transversal. Interior angles on the same side of the transversal. Sorry, I'll just put in this descriptor here. Alternate exterior angles are equal. Interior angles on the same side of the transversal are angles that are on the inside the parallel lines and on the same side of the transversal. So for example, angle D and angle F are inside the parallel lines and on the same side of the transversal. Now while those angles are not the same, one is obtuse and one is acute, they do add up to 180 degrees. Okay, so another pair of interior angles on the same side of the transversal, D and F is a pair, and the only other pair here you might want to predict is angle C and E. Those are interior and they're on the same side of the transversal. So if I was to add them up, it would be 180 degrees. And the definition or the abbreviation for this is that interior angles, and I just put SS for same side, of the transversal, the property is that they equal 180 degrees. And finally, and rather quickly, the last, there is something that can help us with this. We call it the C rule. So if you look here, here's the letter C, okay? And inside the armpits of the letter C are D and F, or if you drew the C backwards, it would be C and E. So I'm going to put the big fat letter C, and I'll kind of do it like this. It's a C rule. Okay, moving on to just triangles. 3 definitions. One is that the sum of the angles in a triangle, so we know that the angles in a triangle add to 180 degrees. So if you look at this triangle, angle A plus angle B plus angle C add up to 180 degrees. And the abbreviation we're going to use is this, is that angles in a triangle equal 180 degrees. Okay. Second last definition is angles opposite equal sides. If we have a triangle here that has equal sides, like this one does, it's called an isosceles triangle. And the angles that are opposite those sides, so angle A and angle C, they're equal to each other. Okay, so in an isosceles triangle, the angles that are opposite the equal sides are equal to each other. So from the example, A is equal to angle C, and the abbreviation for this is just this. Angles opposite equal sides are equal, and you will see an example of that in a little bit. And the last definition, which won't be used extensively and doesn't have an abbreviation, is the exterior angle of the triangle and the sum of the non-adjacent interior angles. That means that the exterior angle, which is this one here, A, is equal to the sum of the 2 angles that are not right beside it. So C and D. B is right beside it. So this definition is that angle A is equivalent to C plus D. And in the next lesson, what we're going to look at is specific examples, which will make this a lot more practical and straightforward.